Hello! Okay, 2D, displaying and describing numerical data. So we've looked at categorical data and now we're going to look at numerical data. So remember, numerical data is data that can be counted or measured, and we can usually tell the difference because there are numbers involved. But as I said in the first video for 2A, just because it has a number does not necessarily make it numerical. So the example I always use is postcodes. So postcodes is given by a number. Okay, so you can have, I don't know what Caulfield is, but I know I live in 3195. Okay, but that's not numerical because it can't be counted and it can't be measured. All right, let's move on. So for discrete numerical data, the process is exactly the same. So if we're looking at organizing it, it's exactly the same as for categorical data. Okay, so we're going to look at the example here. So example 5, constructing a frequency table for discrete numerical data. So the number of brothers and sisters reported by each of the 30 students in year 11 are as follows. Okay, so I'm not going to read them, but you can see it there. Construct a frequency table for these data. Okay, so number of siblings. So we'll put that in order because it's probably the easiest way to do that. So 0, 1, 2, 3. Do we have more than 5? Oh, we have 6. So I've got to kind of fit 6 in there. I actually might not do all of them because it's going to take forever. So as we did before for the lunch, okay, we just count up how many zeros we have. So we've got 1, 2, 3, 4, 5, 6. Okay, and then to do your percentage, we go 6 over the number of students, which is 30, and then multiply that by 100. And I actually know that that is 20%. Okay, so percent. And then you do the same for 1, 2, 3, 4, 5, 6. You should have for your count, the total should be 30, and for your percentage, it should be 100%. Okay, so I'm going to move on because I'm pretty sure you'll be able to do that. Now, grouping data. So some variables can only take on a limited range of values. For example, the number of children in a family. Here it makes sense to list each of these values individually when forming a frequency distribution. In other cases, the variable can take a large range of values. For example, age might take values from 0 to 100 or even more. So listing all possible ages would be tedious. Okay, that means it's going to be a pain in the bum and would produce a large and unwieldy table. So that just means a table that probably wouldn't give us much information at all. So to solve this problem, we group the data into a small number of convenient intervals called class intervals. Okay, so if we were to do ages, and you've probably seen this before, you would probably go 0 to 10, 10 to 20, 20 to 30, and so on. So the intervals should be chosen according to the following principles. Every data value should be in an interval. Okay, so you wouldn't have 0 to 10 and then 12 to 20, because where do the 11-year-olds go? The intervals should not overlap. Okay, so make sure that they don't overlap. So if you're doing 0 to 10 and you're using discrete values, your next section, depending on how you write it, you probably just would, sorry, I should write it here, use your inequality signs. So we're going from, 0 to 10. And are we including 10? If so, you can go write that as age is between 0 and 10. So we're including it here. But on the next interval, we're not including it. Okay. So you can see there 10 is included, but we're not including it there. So 10-year-olds aren't included twice. There should be no gaps between the intervals. Okay, so kind of the same as every data value should be in an interval. But also you might have an interval where there's no values. Okay, so just make sure if you have intervals, you also include them because they're important. Saying that there's no one in an interval is just as important as saying that there are people in an interval. So the choice of intervals can vary, but generally a division which results in about 5 to 15 groups is preferred. It is also usual to choose an interval width which is easy for the reader to interpret, such as 10, 100, 1000, etc. Okay, so if we were doing age, okay, we're doing 0 to 100, 10 categories is fine, or 10 intervals. So 0 to 10, going up in groups of 10 would be easy to interpret. But if we went in groups of 2, it would just be silly. Okay, let's move on. So by convention, the beginning of the interval is given by the appropriate exact value rather than the end. For example, intervals of 0 to 49, 50 to 99, 100 to 149 would be preferred over the intervals 1 to 50, 51 to 100, and so on. So even though I gave that example there, that was just as an example, just explaining what was happening. But as you can see here, it's preferred if it's done this way. Okay. Grouped discrete data. So constructing a frequency table for a discrete numerical variable. So a group of 20 people were asked to record how many cups of coffee they drank in a particular week with the following results. Okay, so how many cups of coffee they drank per week. So you can see here, some people did 0, and then we look for the maximum, which is, looks like it's 34. Okay, so that means we've got to count for everyone between 0 and 34 cups of coffee. Now, we wouldn't do every single one, so here we would have intervals. So let's go, you can do groups of 5, but I'm just going to go groups of 10 so we can see. All right, so let's do 0 to 9, and then 10 to 19, and then 20 to 29, and then 30 to 39. Okay, and then the count. So how many people had between 0 and 9 cups? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and how many people? There were 20 went there. So to do the percentage, 11 over 20 times 100, and your percentage would go there. And then you can go on and do the rest. All right, grouped continuous data. When constructing a frequency table of continuous data, the data are again grouped, as shown in example 5. Okay, so going to construct a frequency table for a continuous numerical variable. So the following are heights of 41 players in a basketball club measured in centimeters. Okay, because it is, measured in centimeters, it is continuous data. Okay, so we're measuring it using centimeters. Construct a frequency table of this data. So you can see our groups here, so 170 to 174.9. So we go on and count all them. Okay, and I'm pretty sure you're able to do that. So just for the purpose of this video, I'm going to trust that you know how to do that, but you can check your solutions if you need to. The interval that has the highest class frequency is called the modal interval or the modal class. Okay, so remember again the term mode, meaning the most frequently occurring. Here the modal class is 180 to 184.9, as 13 players or 31.7% have heights that fall into this interval. All right, cumulative frequencies. So to answer questions concerning the number or proportion of the data values which are less than a given value, a cumulative frequency distribution can be constructed. So in a cumulative frequency distribution, the number of observations in each class is accumulated from low to high values of the variable. Okay, so example 8, calculating cumulative frequencies. So construct a cumulative frequency distribution for the player height data in example 7. So here we're looking at less than 70. So I might just pause this because it's going to take me a while to keep scrolling, but I'll explain it once I've done a few of the categories oh, sorry, the class intervals. All right, so I've done less than 170 and I came up with 0, I couldn't see any. Less than 175, there's 4. Less than 180, so let's go up. Now remember, this is cumulative frequency, so we're looking at what we had beforehand. So I've been crossing them off. So you can see I've crossed off 4 players there. And now we're looking at less than 180. So I'm including those 4, plus now the others that are under 180. So there's 1, it's exciting, isn't it? Just watching me. And 2. So we're doing less than 180. So there's 180. We want less than. So we've got 2 so far. 3, 4. And I might just double check quickly. Oh, 5, missed one. Okay, so we found 5 more, but we've got to add that onto the 4, okay? Because when you think about it, if someone was 172 centimeters, they don't fall into this category here, but they fall into this category, and they also fall into this category. So we have to include the 4 from before. Okay, so these 4 are included in this category. So your cumulative frequency is 9. And then you go and do less than 85. So let's just go up and do that one together as well. So less than 185, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 more added on. So we've got 13 plus the 9 we had from before. Okay, so that's going to give us 22. And then you keep going. So obviously less than 205 would include everyone. So all 41 players. But I'm not going to keep doing that. It's too time consuming for a video. I want to keep them short. Okay, so let's now look at histograms. So don't confuse histograms with a bar chart. They are different. So a bar chart usually represents categorical data, whereas histograms are used for numerical data. So as with categorical data, we would like to construct a visual display of a frequency table for numerical data. So the graphical display of a frequency table for a numerical variable is called a histogram. A histogram looks similar to a bar chart, but because the data is numerical, there is a natural order to the plot. Okay, so that just means we're going from, so if we're doing the heights before, we would start at 170 and would go up to 205, and there's an order. We're not going to have these in a random order. That would just be weird. So highlighted here in yellow, frequency or count or percent is shown on the vertical axis, okay, similar to a bar chart. The values of the variable being displayed are plotted on the horizontal axis. Each column in a histogram corresponds to a data value or a data interval in the data, if the data is grouped. For ungrouped discrete data, the actual data value is located in the middle of the column. Okay, and we'll have a look at a few examples of that. The height of the column gives the frequency, count, or percentage. Now, I'm just aware that this video is getting a little bit long, so let's just quickly look at example 8, constructing a histogram for ungrouped discrete data. So here we've got the number of siblings and the frequency count. Okay, so for our histogram here, your number goes in the middle. So for the first one, 0, we're up at 6. So just make sure. And you can, oh gosh, that wasn't very good at all. Okay, so there it is for 0, 1, 7. So let's just go up. Oh gosh. Okay, and I might just do 2 just because I'm sure my lines are entertaining. Okay, and then you would keep going. You'd also notice that these examples are taken from your textbook. So if you want to complete them or you want to check how you're going, just check in on your textbook, or you can have a look at the scanned solutions, which haven't been done by the time I'm talking about this video first, but hopefully by the time you get to this video, I will have done those solutions and uploaded them for you. Okay, constructing a histogram for continuous data. Okay, so we're looking at this interval here, so 170 to 174. What's this? Hold on, let me just scroll. I had less than, okay, there we go, lesson. Thought I made a boo-boo. Okay, so let's keep going. So this is, the first one is 4. So we're going, oh, terrible table. Okay, that should be at 4. Should probably be a bit lower than that. I'm just going to write 4 there so you know it's not 5, even though it's a little bit below. Okay, and then we have 5. Oh, that's terrible. I feel like I should do that again. But you get the gist of it. And then 13, and so on. Now, if you're wondering why these numbers are different to what we did before, up here, let me just scroll up, it's because this is cumulative frequency, okay, not the actual frequency. So cumulative means we're adding it on each time. Where are we? Yeah. Okay, now I'm going to stop here because I'm going to do another video on the calculator, and this is getting longer than I want it to get. So I'll do a separate video on constructing the histogram using your CADs. But the instructions are here, but sometimes it's good to be shown. All right, bye.